tutorial, we're going to cover masking. What is masking? Sometimes we want to ignore certain assets when we are performing the pipeline computation. There are two common cases where ignoring certain assets is very useful. The first one is that we want to compute an expression that is computationally expensive, and we know that we only care about results for certain assets. A common example of such an expensive expression is a factor, computing the coefficients of regressions. So coefficient regressions requires a lot of data points, and you always need to actually calculate the regression line. So that's actually very, very expensive, and one that you need to continuously calculate for every single day. The second case where masking is really useful is we want to compute an expression that performs comparisons between assets, but only want those comparisons to be performed against a subset of all assets. Meaning we don't want to compare assets versus assets, so we just want to compare it against a smaller subsets. That way we narrow down. So for example, we might want to use the top method of a factor to compute the top 200 assets by earnings yield, ignoring assets that don't meet some liquidity constraints. So it's a smaller universe rather than the whole universe that you want to do, which is again computationally very expensive. Let's look at masking factors. There's really one masking factors and one unmasking filters. But to do this, we're going to switch over to the notebook. Hopefully that you have already cloned the notebook. I'm going to switch over to that screen here. So here we import as we did before, and this is the explanations that we covered. We're going to look at masking factors. So here, let's just say we want to a pipeline to output securities with high or low percent difference, but we also only want to consider securities with a dollar volume above 10 million. To do this, let's arrange our make pipeline function so that we first create the high dollar volume filter, and then we use this filter as a mask for moving average factors by passing high dollar volume as the mask argument to simple moving average. Now, remember what we did earlier in our earlier tutorial is that we do the simple moving average computation for all of the stocks. The difference here is that we create the dollar volume first, then we use those with high dollar volume, we mask and just perform the computations on the smaller universe rather than performing it on the whole 8,000 stocks. Okay, so here we get the 30 days average dollar volume, and then the second one is that we create the filter whether it's more than 10 million or not. Then we calculate the 10-day as well as the 30-day simple moving average, but with a slight difference. The difference is this. These up to this part is exactly the same. The difference now is the mask. The mask here say, look, it's basically telling pipeline, hey, look, I don't want you to calculate everything for all the 8,000 universe. I want you to focus on those with high dollar volume. In this case, more than $10 million, or more than 10 million, I should say. After that, then you calculate the relative difference factors, which is the mean close of 10 minus 30 divided by the mean close of 30. Okay, so the computation now is done on 2,000 rather than all 8,000. It will save you a lot of time, and it will run a lot faster as well. Okay, so that's really masking factors. Now look at masking filters. You can repeat the same mask on filters as well, such as using top, bottom, as well as percentile between. Masks are most useful when we want to apply a filter in the earlier steps of a combined computation. For example, suppose we want to get the top the 50 securities with the highest open price that are also in the top 10% of dollar volume. Suppose that we then want the 90th to 100th percentile of those securities by close price. We can do this with the following. Now, just do a recap. What do we want? We want to get 50 securities, highest open price, top 10% dollar volume, and also 90th to 100th percentile of securities by close price. 3 things. Okay, so here we want the dollar volume, average dollar volume for the last 30 days. We want to get the 90th to 100 percentile, which is really what this top 10% of dollar volume is. The next thing is we want the 50, top 50 by close price, or the latest close price. But the mask here is using high dollar volume, which is what we already done here. Okay, so you use one to mask the other. Okay, so basically we're taking 50 but mask based on high dollar volume, so which is that 50 here. And then lastly, we want to get the 90th to 100 percentile by closing price. So between 90th to 100, but we just want the top open price, which is that one here in terms of the top 50. So basically what you've done here is that you are filtering step by step using the mask vectors to actually narrow down the selections, funnel down so that you ended up with a smaller universe, or computation is performed on a smaller universe. So if we can't remember whether I run this or not, so I'll just start from the top here, run it, run that, and plonk all of this into pipeline. So dollar volume first, dollar volume between the 90th to 100 percentile, use that as the mask for selecting the top 50, the stocks with the highest opening price, and then use that to as a mask for those stocks with the close price that is between 90th and the 100 percentile, and finally use that as a screen for our pipeline. So if we run that, it will only have 5 securities. So this is another term for this is called asset funnels. So that's really the end of this video. We're gonna go through and look at classifier next. Thank you.